Hello, in this video, want to show you how to perform a quadratic discriminant analysis using R. So we have done the linear discriminant analysis in which the discriminant function is the linear function of the variables. Sometimes maybe the linear discriminant is not complicated enough. For example, if the boundaries have curve linearities, we may need a higher order discriminant function. And quadratic discriminant analysis a direct generalization of linear discriminant analysis, in which we use quadratic function for the discriminant function. Okay, so the purpose of this video is just show you how we can do a QDA in R and how do we examine the outputs from a QDR analysis. First, let me load in the three variables, mass, caret, and ggplot2, set a random seed, and I want to create a data set with three classes, sample size 300, and then for the class 1, class 2, and class 3, then here are the counts, 90, 120, and 90. Okay, so class 2 had more numbers of observations. And specify mean for each class. And here's the mean vectors. And specify covariance matrix for each class. And so this is a pretty complicated list for class 1, class 2, class 3 have a covariance matrix, and they were chosen to be different. Okay, and then we generate the data for each class using the multivariate normal function to do the random sampling, use the means and covariances for each class, and then we put them together. And shuffle the data set, and here's what it looks like. So we get a class, the y variable is class 2 or class 3, class 1, and we get x1, x2, x3, x4, x5. So the purpose of the discriminant analysis is to use x1, x2, x3, x4, x5 to classify y into the three classes. Okay, let's set another random seed. Since we want to do a training sample versus a test sample, so we've created a train index and split the data into train data and test data. And to perform QDA is very simple. QDA is in the package mass. So the syntax is QDA y tiered dot and data equal to train data. So we're training a discriminant function for y as the dependent variable and all the rest variable x1, x2, x3, x4, x5 as the predictors. And we're doing this only on the train data set. So that's fitted. We can print it out and give us the means and look into the prior probabilities of groups. We got 0.3, 0.4, and 0.3. So the prior probabilities are not equal. Okay, we have an unbalanced sample. And of course, this QDA underscore model is much more complicated than just what's printed out by the print function. So here is the structure of the object. You can take a look what's in there. So when we complete this QDA, we can look at the output different ways. So first, let's do a prediction using the fitted QDA model on the test data. And then we start to look at the accuracy of the prediction by creating a confusion matrix and then print out the confusion matrix. So here, look like it's highly accurate. I got about 6 misclassifications, but all the rest are perfect classifications. Okay, and we can also look into the posterior probabilities, and this is the QDA underscore predict posterior. We print out the first 5. You can see the observations, and you get the class posterior probability. So for the first one, we see the class 2 has 0.999995. So that's much larger than the other 2 posterior probabilities. So this observation likely belongs to class 2. Okay, and of course this posterior probability distribution has 90 rows and 3 columns. Okay, so we can also look at accuracy, which is the totally correctly classified number of cases, the percentage, that's 93%. It's pretty good. And also we can do some visualization of the decision boundary. Okay, so this more complicated. Let's create the range from x1 and x2, and then create a grid, and then we add grid x1, 3, x4, x5 to a prediction of the class, and then put them into this grid class variable, and this is the data set, the grid data set we created. Then we use that to plot out the boundary. Okay, you can look at that. This is x1 versus x2, and you can see the 3 classes with different colors. It's I look at the, it's a little bit difficult to see the colored dots, but you can see there's a little bit overlap, but mostly they're pretty much separated. Okay. Another analysis we can do is the ROC analysis. Basically, you have a categorical dependent variable in a bunch of continuous. You have a continuous marker. So here, the discriminant function is a continuous marker. So then we can create a ROC curve. So this ROC curve would be a ROC curve on the test data, but the Y is the class 1 versus others. So this is really for the ROC curve for classifying class 1. And we get an area under the curve, 0.98. It's very, very accurate. Okay. And also we can plot the variable importance by plotting out the bar charts. And this is really the means of each variable. And the taller the bar, the more influential of the variable on the classification. So here we see x4 has the largest influence and x2, x3 has smaller influences. Okay, and we can compare models. So we did a QDA, and what if we just did an LDA, linear discriminant analysis? We want to see how much improvement in the accuracy we get. Okay, so we can fit an LDA model using LDA, and we predict on the test data set, create the confusion matrix and the accuracy, and here's the accuracy here. So the accuracy is also 93.33%. Okay, so probably we don't really need a QDA here, but okay. And then we can set another random seed, do a cross-validation. This is a function train is from the package caret, a machine learning package. So we want to do a cross-validation. It's tenfold cross-validation just to see how accurate this prediction model for under the cross-validation conditions. Okay, So this is a command, and I'll print it out. And now the accuracy is down to 90%. So this is a kind of reduce the influence of overfitting to the data. So it's become lower accuracy, and also the kappa coefficient during the agreement for the agreement of the predicted versus the observed class memberships. Okay, so 85 is not bad. Okay, so this is a tutorial for QDA to show you some of the basics, what we can do with QDA. Thank you.